again welcome everyone. So in the first hour, we are going to give like a basic introduction to green hydrogen system, and also we are going to discuss some of their practical application, mainly targeting the electrical, power grid and also electric vehicles. So I am not going to spend time on that because you already have seen this one. So hopefully, I mean at the end of the course, you will have some basic understanding about the whole green hydrogen system, including electrolyzer, fuel cell, different inverter, converter, and also different topology of inverter, converter, some technique for designing control, and also some application like hydrogen based microgrid. I mean how we can design and then optimize, and also we are going to give some demonstration in the tutorial using MATLAB, how we can design and analyze like the device level as well as system level performance as well. Now, these are the total content of this subject. So, we are going to start with introduction, and then we are going to go for the hydrogen technology, for example, electrolyzer and fuel cell. Then we are going to talk about inverter and converter, like DC to DC, DC to AC, and AC to DC as well. And then we are going to also talk about how we can control different inverter, converter, and also the system level as well. But among the inverter, we are going to also particular focus on grid following and grid forming inverter, because you know that these are the two like emerging technology for interconnecting not only hydrogen, but also like other storage like battery energy storage system, but they are also thinking for connecting for renewable energy based as well. But so far most of the grid forming inverter, they have been used for with the battery energy storage system, but having said that, it can be also utilized for other technology as well. And then as I say, like we are going to also talk about the microgrid level as well, and at then we are going to also talk about how this inverter converter technology can provide ancillary service to the grid, which is already having problem with both voltage, frequency, as well as sometime small signal and transient stability as well. And then we will finish by explaining something on standard policy regulation on like green hydrogen systems. Now, these are the content I am going to cover. So just gonna talk one by one. So I will start with like background to climate change and so on. So in my previous talk I already mentioned that due to like different human activities, so all country having problem with greenhouse gas emission. Now here I am just showing some statistics for Australia. So here you can see that only like the agriculture sector, so the greenhouse gas emission have actually reduced significantly, but other sector, although they have reduced slightly, but still almost like going on almost like at the same level. So there are certain like reduction, but to get that 2050 target, we have to actually reduce that greenhouse gas emission not only from electrical power sector, but also other sector like transport, agriculture, and also like education and other sector as well. Now again, like in Australia, as I said, like that we have got target for by 2050 to go net zero. I think in India they have little bit behind Australia. They are targeting like 20, probably now 2070. But if you see here in the right hand side, I think most country, European, so most European country, they have got in between like 2040 and 2050. Now in Australia, although like as a country we have got 2050, but actually different state they have got different targets. I am from like New South Wales. In 2030, and they have got a target by 35%, but definitely by 2050 it gonna be like 100%. And other state, they have got different target to reduce their greenhouse gas emission by different percentages. Again, this is again I already mentioned, like for India, their target to go net zero by 2070, and here are some statistics probably you already know. And for greenhouse gas emission, you know that there are like mainly three types of emission, type 1, type 2 and type 3, but type 2 is mostly related to the electrical energy uses. So for electricity network, our target mainly to reduce the emission coming like type 2, which is mainly from generation, transmission and utilization of different renewable energy, different energy resources. Now, although like different sector contribute to go for greenhouse gas emission, but as you know that the electrical power network, they are actually one of the major contributor for carbon dioxide or greenhouse gas emission. Now, it's not like that only if we go for 100% generation coming from renewables, we can address all of the challenges. So, due to that energy transition, the different sector in power system, like including generation, transmission, distribution and even behind the meter, there are actually many things happening. For example, if you think about generation, so as you know that currently most of the existing centralized fossil fuel generator is being replaced with renewable sources. So, the transmission sector, although like is comparatively intelligent than distribution, but still in the transmission sector also there are several changes happening. For example, in recent year you will see like many phasor measurement unit for remote area monitoring as well as control as well. So, in Australia actually we do have number of phasor measurement unit that actually installed in transmission sector. And also in recent year, as you know that the power electronics, which is getting like almost one of the most important component of the whole power system. And in recent year in the transmission sector, you will see different power electronics control. For example, different fax devices like STATCOM, SVC and so on, but also you see grid following, grid forming inverter as well in the high voltage system as well. And in many cases like high voltage DC, although high voltage AC is the most common for energy transmission, but high voltage DC also getting popular for interconnecting offshore wind farm and also to interconnect for long distance transmission, mainly in the Europe, where they are connecting different countries with the high voltage transmission. In Australia, we do have like one high voltage DC, but other than most of them actually high voltage AC. But in recent years, actually the biggest changes happening in the distribution sector, because as you know, the distribution sector in many cases like the manually controlled. You see in many cases, if something happen in the distribution sector, if for example, let us say the transmission line is disconnected for some reason, then what we do? We call the transmission operator, they come and then manually fix the problem, and it takes sometime like week, sometime more than a week, right. So, that is why to make the grid like a smart grid or intelligent grid, whatever we want to say, we need to make the distribution system like an automated and intelligent. So, that is why in recent year you see like the most of the research effort and also investment from different utility, government, they are focusing more on the distribution side. And as you see that most of the small size distributed generation like the rooftop PV or small size wind turbine, small size battery, all are connecting in the distribution sector. And also another new technology you might heard about microgrid, which is also getting popular to supply power in the remote area and also improve resiliency to supply power in the critical load. For example, let us say hospital, different important laboratory and so on. So, that also connected in the distribution sector. You will also find smart meter, which is also getting quite popular to get like almost like real time energy uses, the price that we are paying, and also if we have got different appliances in the home, university or so on, we can also see like which appliances using how much energy and what money you are actually paying for what appliances, and that can actually help you even to reduce your electricity cost depending on your personal requirement, and that is actually getting quite popular. In Australia, in some state now they have almost like 90% meter in the home like the smart meter, in some other state like 30-40%, but all the state now they are moving to have more smart meter. And then the new load that either hybrid or plug-in hybrid, they are also connected in the distribution sector, and the technology like the green hydrogen, which is we are going to talk, that might be in the distribution, but also a big size can be in the transmission as well. And also many things even happening behind the meter like zero energy home, demand response, and also many things happening in the electricity market as well. Now, you know that the hydrogen is not a new technology. It has been like in many countries using for different application for many years, but in recent year actually is getting momentum for mainly to address the issue as I said like for climate change, and also to get that net zero target, to decarbonize the transportation as well as electrical sector as well. And the reason because it is getting popular because it has got very high energy density, and also it is quite lighter if you compare with other type of fuels, and there are not like significant greenhouse gas emission if you produce hydrogen from renewable energy sources. And this one is just showing like the total value chain from green hydrogen system. So, although we are going to talk about mostly all of them. So, it does involve like production, and there are many methods that we utilize for production, and we are going to touch most of the method like gasification, electrolysis, and then steam methane, gasification, although we are not going to focus more on the carbon capture, but with some of that blue and other hydrogen system we do use carbon capture, because that type of hydrogen actually emits carbon. Then we are going to also talk little bit about like combining gas and electricity network, and there are some research going on, like combining these two methods and then improving the combined network, and then it does involve storage, and hydrogen can be stored in different form, as the liquid, gas, and even solid form as well. It does involve different application in the transportation and local infrastructure as well, and then we do have already number of end user for heating, vehicle, and residential commercial application as well. Now, as this subject more on the grid connected, and this one is showing like how that green hydrogen system in different way actually is connected with the electricity network, and it does connected with the gas network as well. So, what I am trying to say that there's gas network, electricity network, and also the hydrogen, they are all interconnected. Now, at some stage, I mean, we can actually optimize and improve the performance of individual system, but to get actually the better benefit, sometime we might need to have the combined model for the whole system, I mean, to optimize the and also benefit from the coupled system. Although sometime I mean it's not that always you have to consider the combined model. For certain application might be you can just consider either device or part of the whole system. But as I said, if you want to have the whole value chain, then sometime you need to develop the model for the interconnected system as well. And if you combine that all system, it does actually have number of issues. It's not like the electrical, but it does involve like the environmentals, because it uses water, it does use land, and also as we are going for more cleaner, but it still there are some carbon emission as well. And the other factor also we need to consider the economic issue as well, because as you know that we could have very resilient and very energy efficient project, but at the end if it is not economically feasible, I mean no government or industry gonna adopt either your design or your model. So, at the end whatever we do, although it has to be optimal energy efficient, but at the same time although we need to show that it is economically feasible as well. So, at some stage I mean we are going to talk about some of the economic parameter when we have the system level design as well. Now, again I mean you might already know about this, I mean different types of hydrogen. I am not going to spend more time on that. So, you know that we already using most hydrogen either gray or blue. So, the gray is mostly we are having from fossil fuel, using either coal gasification or steam methane reforming, and the next one is blue. Blue, the only difference with that one that we use carbon capture and storage. So, whatever the carbon is emitting from this process, we use that technology I mean to capture and store it, which making more cleaner than gray hydrogen. And finally, this is the most economic one, and I think in the next generation technology would be the green hydrogen, where we use the input energy from clean sources, and then we use the electrolysis process I mean to generate green hydrogen, and it does not actually emit any significant carbon I mean from this process. Now, although I mean we have later in the lecture more details about different process, I mean how we gonna produce hydrogen from I mean different sources, but here I am just gonna give a quick overview of different processes. So, for example, that steam methane reforming, which is again already utilized in different countries, and here we normally produce from like the natural gas. It has got comparatively higher temperature. It could be from 700 to like 1000 degree. Definitely in the process of in the presence of the like a catalyst, and you know that all like electrolyzer, they do have electrolyzer, and we are going to talk about that later. So, in steam methane reforming, it does produce hydrogen, also some carbon monoxide as well, and even a small amount carbon dioxide as well. Now, later this carbon monoxide again we reutilize to produce actually more hydrogen, and then again it does emit some carbon dioxide as well. And as I said, like this is so far is the most dominant hydrogen production method in different countries. The electrolysis, as I said, like we are gonna give more focus on this technology because it use like mostly electricity to split water, and there is no burning process, so it does not emit any significant hydrogen. So, it does produce hydrogen from water, hydrogen and oxygens. And there are different types of electrolyzer we are going to talk about, but as you know that alkaline and PM, that are the most two preferable one normally mostly used in the electrolysis process. And there are some thermochemical process also used, that uses heat and chemical reaction, heat from sunlight, and then they release hydrogen from like different feedstock, fossil fuel, and also it could be from biomass as well. And also you might also know that the solar concentrator, even the nuclear reactor, that also can produce that needed at very high temperature using the process to produce hydrogen. And also there are other method biological that also use like bacteria and algae that can be produced hydrogen from biological reaction as well. So, again just is highlighting that different path from renewable solar, just like water is spilling, that's it could be produce hydrogen, and then using electrolysis, solar, hydrogen, geothermal, that also could be produce hydrogen, and then from nuclear, and also from fossil fuel and process also we can produce hydrogen as well. So, there are different pathway, but in this course we are going to more focus on the electricity using the electrolysis process. Although it might be difficult to read, but it's just giving like some comparison using different method, mostly important parameter could be that efficiency that we are getting from different method, and also cost, considering the base cost like the current one is steam methane reforming. So, compared to this one, how the cost for other methods, and which technology which are already matured and which are still going more research and development to improve the efficiency, safety, and so on. So, now again I am just gonna go quickly more details about that different method that we can use for hydrogen production. So, steam reformation, I already mentioned that this is one of the most matured and commercially established process, like people different industry, they are already using to produce ammonia, to refine petroleum, and in some cases hydrogen energy system as well. Again, this is comparatively among the existing commercially available method, one of the cheapest method. And again, we are going to talk about that there are mainly 3 component: anode, cathode, and electrolyzer. So there are some chemical reaction happening both anode and cathode, and here you can see that from that methane gas using water, it does produce hydrogen, but also it produce some carbon monoxide as well. And again, using that carbon monoxide, we again use with water, and that can actually help to produce more hydrogen. But again, you can see that still it emits some carbon dioxide as well, and that's why we need some carbon capture if you want to make this hydrogen comparatively more cleaner. It has got some advantages. I already mentioned, like it more matured, relatively low production cost, comparatively higher efficiency, but it does have some limitation in terms of carbon dioxide emission. It relies on fossil fuel, mainly the natural gas, and also it need higher energy input required process, because the process is highly endothermic. There are number of applications. I already mentioned that ammonia, petroleum refining, methanol production. It can be used for fuel cell if coupled with carbon capture and storage, and it has use because it can be used like a blue hydrogen when we are integrating with carbon capture and storage technology. And this is as I said, the our most optimal and also desired process in coming years to produce hydrogen from different renewable energy sources. So energy might come either from solar and wind, and using that electrolysis process, we can produce hydrogen, but at the same time also it gonna produce some as a byproduct some water as well. For this one, this is more like scalable, flexible, and also it could be distributed for hydrogen production in any area you want. And this is again we many times talks that it use energy from renewable energy sources. So if you compare with electrolysis and steam methane reforming, so the cost again this is one of the factor that this is again relatively cheaper than electrolysis. It's more matured, but it has got definitely higher emission, and for this method it's almost like zero when you're gonna use the input energy from renewable sources, and it uses mainly water, electricity, and that one uses like fossil fuel like the natural gas. So we already talked about that advantage. I'm not gonna repeat that one. So still if you think about the cost producing the electrolysis, like in Australia we have got still like $5 to $8 per kg, but to make it comparable with other gases, it has to be like $2. So there are so many project research work going on. How we can reduce the price by reducing the price from hydrogen technology, by reducing the price of input electricity, and also by improving the energy efficiency for the whole system. And not only that, also I mean, so far the production is only very micro scale. So, if you can have production very macro level, that also gonna help to reduce the price. Hopefully, I mean that might happen in next 5 to 10 years, and if it happens, then I mean green technology gonna be used for different industry like ammonia, methanol, steel, cement, even for different transportation applications, energy storage, and more importantly, it gonna be connecting in large scale with the grid to produce different support to reduce might be peak demand, to improve power quality, and also to provide ancillary service like to control voltage, frequency, and so on. Now, the third methods, the gasifications. So, that is again I mean thermochemical process that converts like energy available from coal, biomass, and water into syngas, which primarily consists of hydrogen, carbon monoxide, and then carbon dioxide, and also a small amount of methane and other gases as well. So, that could be like different feedstock that can be utilized to produce hydrogen using this process, and it also operate very high temperature. If you compare with like the previous one, electrolyzer operate like very low temperature, and this method actually need controlled actually oxygen. And these are the like very simple chemical reaction that's happening in anode cathode, I mean to produce hydrogen. So, again I mean this is quite well known, and I believe all of you already know about this. Again this one also have I mean different types of application to produce hydrogen, synthetic gas, ammonia, methanol, waste to energy production, and it does actually convert low value and waste material into usable energy. So, that is one of the important advantage of this method. It has got higher efficiency if you compare with the direct combustion, but it does have number of limitation as well, because it does involve capital intensive technology. It produce carbon dioxide unless we use carbon capture and storage technology. In terms of like the overall process is most complex, and we need to like have good control, I mean to control the overall process. And this is giving like again I mean comparison among three methods, but I think we already talked about most of this. So, in this case like both are quite matured and commercially available, although this one commercially available, but still I mean is growing. So, maybe still I mean we need further improvement of all the fuel cells as well as electrolyzer technology that is currently available. The biological, that is another methods that utilize bacteria and algae I mean to generate hydrogen through that natural metabolic pathway. So, using like in the light from sun I mean and also water, I can actually convert that one to hydrogen and oxygens. These are the organisms that actually use. So, this is also like could be one of the quite popular method in coming years. So, the only challenge is that it has got oxygen sensitivity, that actually limits some side the efficiency of the overall methods. So, there are some indirect I mean biological methods as well that also I mean have two step, I mean that actually can produce hydrogen from biomass using the photosynthetic methods. So, you can see that from glucose and water using light and bacteria it can actually produce hydrogen, although it does have some carbon as well. And also the dark fermentation, that's also another method could be utilized to produce hydrogen from glucose as well. That's we already talked many times, like what is green hydrogen, and what are the different application, and why actually we call this green. That's you already know about that one as well. We already talked about that that it does have anode, cathode, and this electrolysis membrane, and then like that input energy coming from renewable energy sources, and then in the cathode from water and input energy, it does actually produce hydrogen, and using that hydrogen ion and oxygen, it also from water actually it has got the oxygen, this hydrogen ion, and this hydrogen ion actually pass through the membrane like to the cathode, and then using that hydrogen it actually ion it produce actually the final hydrogen. I'll also skip this slide because you already have it, you can just read later. That one also we already talked about that impact of different green hydrogen technology on different sector. For example, in environment, it does help to reduce greenhouse gas emission. It can have impact to improve air quality, and also it can produce solution that's number of the problem that actually had been introduced by large scale renewable energy integration. For example, in Sydney is what happening in different state, like off peak time. For example, in the morning and afternoon, we have actually the additional renewable energy generation. And in many cases what happened that, for example, if you have got rooftop PV and you are producing energy, so if you supply energy in the grid during the off peak time, so instead of grid actually providing money, they actually charge you, because what happening that they already have enough generation compared to the load demand, and when we are supplying additional energy to the grid, actually it producing more problem to the grid. So power quality, voltage and frequency issue. So that's why they actually have negative tariff. That whoever supplying additional energy during the off peak time, they are actually have pay back money to the actually grid operator. And hydrogen actually could be a very good solution to resolve that issue, that during the off peak time hydrogen can be utilized, that additional renewable energy can be utilized to produce hydrogen during that off peak time, and then it can be utilized again using that fuel cell again to produce electricity if needed. Although so far we are not producing any electricity from hydrogen, mostly it using for transportation, heating, cooling, and other industrial applications. Now, in Australia, we already have number of projects, some of them ongoing, but some of them is already actually producing green hydrogen as well. Now, one of the biggest project now happening in in Queensland, in Brisbane, where actually they are the government is spending almost $15 billion. So they have got a big suburb where we have got number of different industry, commercial and residential. So the whole area actually they're gonna supply different heating, cooling and all the industry, and different like transportation application. So, they are gonna using hydrogen from that particular area. Not only that, we are also having number of renewable energy hub and renewable energy zone, where we do have the option including hydrogen in those energy hub, as well as renewable energy hub, as well as renewable energy zone as well. And in New South Wales government, now they are targeting number of like the offshore area, like there are 5 areas they have already targeted, and the work has already been done to have 5 hydrogen hub, and in those hydrogen hub they are also installing like offshore wind as well. Not only that, in different areas like also in Victoria, in New South Wales, there are already number of projects, some of them like under construction, and some of them already producing actually green hydrogen as well. Now, this is again there are some other project as well, but some of the project, for example, this one organized by CSIRO. So, this is more like research and for testing facility they have got. So, most university, whatever research we are doing, if we do not have like infrastructure for practical implementation, actually the university and other industry who are doing like research and demonstration, they can actually go and doing experiment and validation with that research organization as well. And like in terms of transportation application, so in Australia already we have like 12 hydrogen refueling station, which is out of 12 I know like almost like 6 they are already operational, because in Australia we do have number of hydrogen powered small car, but that number is not that high. But in terms of like heavy vehicle like the buses, trucks, there are actually number of them in different states. They are already running, and they can easily get that hydrogen fuel from those fuel station. And as you know that if those vehicle use like battery, mainly for heavy vehicle, they need very longer time to recharge the battery. Another option to have number of batteries, which make also the system like the overall it would be like bulky as well. So, for those reason for heavy vehicle, as you know that the hydrogen would be the best solution. But having said that, still there are some hydrogen car available in Australia as well. And as I said, like in most states that we already having hydrogen fuel station that's already operational. And also like in India also, like you have number of projects that's ongoing, and I know that India and Australian government, they have number of actually discussion and talk to work together in this sector, because we also have potential that maybe this country like they can export, not only utilize, but also they can export hydrogen to other countries as well. So, I already mentioned like different application, that battery already we are having different application as well, but also the green hydrogen that will have even like bigger application in grid, even in ships, steel industry, even like aviation. Aviation is also like already number of unmanned air vehicle that they are already using hydrogen also, and also like the different fertilizer industry and other chemical industry also, they might be using hydrogen in coming years. Now, this is also I already mentioned, like that fuel cell application in heavy duty vehicles and long haul transportation as well, and this is the technology already available. Only the issue is the price, but as you know that even both like the battery and hydrogen price, even like the battery price, actually they are coming down significantly. Like in every years the battery price is going down by 15%. So, almost like in 3 years battery price is going down like 50%, and if that trend continue, I believe in like next 5 years the price for like IC engine based car and battery vehicle car would be almost like quite similar. Although hydrogen, it might take little bit longer, maybe 5 to 10 years like to going down the price, but the way that both the research development and going, and most like government, they are actually spending heavily in this sector. So, we are quite hopeful that this time definitely hydrogen gonna be like one of the dominant fuel in coming years. So, yeah, it's not only transportation, but also in decarbonizing the different sector, because in many cases you will see that some of the industry might not be directly electrified. So, in those cases to decarbonize that, hydrogen could be like one good alternative potential. So, it also can be used, as I mentioned, like in oil and gas refinery sector as well, in different like chemical production, and also steel, cement production, methanol production. In those industry also, in Australia already one of the steel and cement production, they are already using the green hydrogen to decarbonize the sector, because in Australia what happen in any industry, if they produce like green carbon dioxide beyond certain level, actually there is a penalty. So, that is why most industry, they are also trying to have like different alternative option to reduce their greenhouse gas emission, and that is why they have already started to use like green and blue hydrogen using CCS to meet their target. And energy sector, as I said, like still there are not any like large scale integration happening, but if you want to have like 80%, 90% renewables, then definitely we have to think beyond only battery, because the battery have got like capacity only maybe few hours, but if you want to have like very longer duration storage, then definitely hydrogen gonna be like better solution. So, in definitely the energy sector, it is gonna be using to solve many of the problems that we are gonna discuss in coming lectures. In the heating, already in some of the area in Australia, that's already they are using green hydrogen for heating application. Food, already many of the food industry, they are also in the process of thinking to utilizing hydrogen for their food production as well. Many semiconductor manufacturing industry, they are also thinking to utilize hydrogen in coming years. And as I mentioned that that different country, they have got like different forecasting like about their upcoming hydrogen consumption as well as hydrogen export. So, in Australia, we have got different scenario, considering like business as usual, or like a step change, or gradual change, but whatever way, definitely the consumption of hydrogen gonna be significantly increased in Australia, but in Australia actually the main idea is not only the national consumption, but also to export hydrogen in country like Japan, Germany, Korea, and it could be between India, Australia as well. In India also I found that they have also some forecasting that in coming years they are like hydrogen market gonna be increase significantly. The way that different industry, government, they are investing. So, it is not only government, the private sector, they are also coming in this market. So, that is going to be helping to significantly increase the hydrogen market as well. And also like not only India, Australia, but USA, China, European countries. So, if you see like if we consider like the worldwide scenario, by 2040, 2050, the demand gonna be increased significantly. So, definitely it's like a growing technology, and as I said, this is also quite exciting nowadays to working in this area, because as I say, most of the green hydrogen technology, they are not matured, and there are number of challenges. And when you have challenges, definitely there are several opportunities as well. So, those are you are thinking, although I am going to talk about more about different challenges, mainly the research challenges in coming lectures, but those of you are thinking to give more focus in this area. You can see that there is a quite significant challenge to address the intermittency. If you think about while hydrogen, different renewable energy, all are grid connected, because like when we have got like in Australia already we have got around 40% coming from renewable, but in some state like Tasmania and South Australia, they have already have close to 100% coming from renewables. So, there are when you have got 100% renewable and they are intermittent and the output power are variable, in many cases they are already having issue with the power quality. And also there was a big blackout in South Australia when they have got a problem like fall right through with the wind turbine, because they are having like 50% power coming from wind. And what happened, like there was a transmission line disconnection due to such severe weather condition, and for some reason actually they did not actually activate the fall right through of the wind turbine. And what happened, as that fall right through was not active, so when there is a disturbance like voltage frequency got outside and the whole wind farm was disconnected. And then what happened, like there is an interconnection between like South Australia and Victoria, and the interconnection, when the local generation significantly dropped, the power exporting from other countries, they exceeded the capacity of the transmission interconnection, and that's how the whole state was like blackout, and it took almost like week actually to solve that issue. So, in that regard, although already the fall right through capability already included many of the existing technology, but to address that overall intermittency, both like planning, operation, we still need more research and development work when mainly considering the system level. Although device level, we need to improve that electrolyzer fuel cell, but I think the more challenges is still in the system level. So, grid stability, that also like a quite growing challenge, already like 20-30% renewable, but and in Australia already like 3-4 like real events already happened using that like even like 20-30%. So, they actually monitored and see that in number of cases in 2-3 areas recently there was like a instability and blackout scenarios, and when they capture the data from PMU, they found that actually like that small signal stability coming from interaction between different inverter, converter and controller, because you know that when that inverter converter technology is coming from different manufacturer, they always I mean design the controller based on their own modeling, and in many cases they actually did not share what actually they have inside. So when that different technology coming from different manufacturer, and in many cases actually their controllers are not coordinated with respect to controller available in other like devices. In many cases, sometimes during their internal interaction between the controllers, they actually have instability issue, sometime small signal, or sometime could be the voltage stability issues as well. The cost we already mentioned, that's high cost. We need more research to reduce the price, and also that improving mainly that technology PM, because this has got probably more opportunity to utilize that technology, because it has got better performance and also very fast compared to other one, but also it needs more research, to improve their efficiency, their lifetime, and also adaptability to work in different environment as well. Renewable energy and catalyst, as you saw, that this is like one of the major element for responsible for higher cost. So we need more research to find lower cost catalyst, and also that can provide better performance. But the people who are working in material science, probably they can contribute in that regards to improve their performance. There are also limitation in terms of infrastructure as well, because for hydrogen storage transportation, mostly if you see all the existing infrastructure, they are either unavailable or even in many cases underdeveloped. So in Australia, they are thinking blending hydrogen as well as the existing pipeline, but still there are many challenges and it doesn't happen still. So they are still thinking, how can they do that? So if you also want to produce large scale hydrogen, we need very reliable and cost effective distribution network to supply hydrogen from production to the end user. Grid integration, that I already mentioned. That's also we need better planning and management to ensure stability and reliability of the overall sector. But also safety, that is also another reason. Still many people they don't want to buy hydrogen car, because they said if there is accident and if something happen, that might be very dangerous for the driver and as well as the passenger as well. So that public reception is still, that's a problem, but we need to work with different people to better explain about the technology, their advantages, and also the safety level as well. Because at the end, as an engineer, whatever we do, if it is not accepted by the community, it's never going to happen in the commercial level. So that's why as an educator, industry leader, we need to also work with the community to convey the real message to the industry as well. And as this is a new area, also we need new standard, mainly to interconnect with the grid, and also deploying in the different industry. So we need to improve all the different IC, IEEE. There are some standard, but we need to work more to improve the standard as well. And also the different country have got different regulations. So sometime also if you buy some technology from one country, sometimes you cannot directly use in other country, because their regulation is different. So that's why different countries, they also need to work together to unify the regulations, so that whatever technology happening in any country, they can use in other country as well. But also the other biggest challenge is the policy that's always developed by the politician, which is completely beyond our academic capability. So whatever we do, unless country have got a policy, it's not going to be employed in commercial level. So again, with that, probably I'll stop now. So these are the probably things that we cover mainly from that introductory discussion. In coming lectures, whatever we covered, we're gonna be having in detail discussion. But whatever we discuss, if you have got any comments, any quick question, or even any final thought, feel free to share. Attention. Thank you.
Right. So it could be just electrolysis, it could be reforming with carbon capture or some other methods, or even as a byproduct of some other processes. Is there some standard on purity levels, or the kind of hydrogen that is produced, or is it all completely fungible and you can take anything from anywhere and introduce? Is there?
No, definitely. When I'm going to be actually talking more details about all those method and technology, there is actually requirement that some of them cases you need very pure hydrogen. If you don't have pure hydrogen, again talking either electrolyzer and fuel cell, one of the cases input, other cases output. But actually that impurity can have significant impact on the deterioration of the and also the life cycle of the technology itself as well. So yes, definitely the impurity either in terms of input and output gonna have not impact on the lifetime of the device level itself, and also in many cases when you're gonna be having a real application, they also have standard that it has to be maybe pure by that percentage. So in that cases also we'll be having some limitation in some of the techniques that we're gonna utilize. But again at the end, the way that you're gonna be deciding that probably I want less costly, but you're gonna be compromising with the quality, then probably you're gonna use one method. But if your requirement, let's say I want very high standard pure, cost is not a major factor, that maybe you're gonna be go for very high standard technique, maybe electrolysis and other process. So
I agree with that. My only question was actually, is there a way or is there a potential to match these sources or requirements today? Because my understanding is that some industrial process like steel, for example, right now they depend a lot on coal. If you were to simply use hydrogen instead of the coal, first of all, you eliminate the carbon from coal completely. You don't have to struggle so much. And then the hydrogen is, I think, from a process point of view, it's slightly better. But there, I don't think that you need very high purity hydrogen, because you don't really care that much about hydrogen impurities. So my question is, if there's a fuel, if there's an electrolyzer or something that is essentially doing renewable to not very pure hydrogen, can we then have it directly piped to, let's say, a steel industry or cement industry where you use it for reduction, and then don't care too much about purity, versus having to struggle with, okay, now I want to change it back to energy, for which I need good purity, otherwise my fuel cell will degrade, or I want to use it for transportation where maybe safety and again you have to compress it, all those problems are there. So do you see that there is some roadmap over the next whatever, maybe say 10, 15, 20 years, where these things can be matched to each other? Let's say low cost mass scale solar, where I don't even care about efficiency, right? So let's say I have, in the outback you can put,
Yeah.
acres of solar, and solar cost is already down in, cents and
That's right.
whatever. So let's say I don't care about solar cost. I have enough space, and just use it for something that it can be used for. So is there some matching that you see, or do you think that there's still some piece that is missing, that something can't be matched to everything else?
I think that's a very good question. I mean, what happened like in perspective of Australia, like in the previous government, because they were not only like very biased among like the electrolysis process, so they actually invested a lot to see like how actually they can improve that existing mature technology that's we already talked about. So they tried to see like whether that's gray, blue hydrogen producing using different method even can be utilized with the CCS to get their target. And they are actually that time they are having number of projects actually to see that not only using the single technology, but what about that we use like a mix of all that available technology, and then finding a unified way that somehow we can combine all together and utilize. But what happened like when the government changed and then the current government came, and they come up with their issue that they're going to be heavily investing in the mainly the renewable and electrolysis process. Then now the momentum has little bit shifted, and they are more biased now to going for that only electrolysis process. But having said that, in Australia I did not see anything like combined effort from industry, government, academia to see the issue that you mentioned, to make it reality. But I think still there are some research industry work still going on that other pathway as well. So I believe it's still not actually happening in the unified level, but it might happen at certain stage, because I think still you believe that we need actually mix of solution, not like a particular single solution that can solve our all problems. Yeah.